Today, I'm here to tell you about one of the chemicals that you have already been introduced to, sodium bicarbonate. And this substance is one of the most useful substances to have around the house. But first of all, I'm going to tell you where you find it. You find it in mineral springs. You find it in bile in your liver because it helps to neutralize the acid in your stomach. And artificially, it also can be made. In fact, hundreds of thousands of pounds of this product are made every year because it's so useful. And I'm going to tell you about also what it's called, other names, AKAs. Of course, baking soda, bread soda, cooking soda, sodium bicarb, just bicarb, and there are so many uses of this product. Well, first it's used for leavening, of course, making bread, delicious bread. You see those little holes are made when acid components react with the sodium bicarbonate, and CO2 is created. CO2 is made, and then it bubbles up and it causes the fluffiness in your bread. The other uses are, of course, here's making cake, delicious cake. Yum. Mm. Mm. It can also be used for putting out small fires. That's important too, because it produces CO2, and CO2 smothers flames. So that works pretty well too. And if you eat a little bit too much of the bread and the cake and all of those things, you put a little bit of this in water, and you swish it around, and you drink it, and it's a great antacid, and it settles your stomach and makes you feel better. And if for some reason you're drinking your coffee and you happen to spill it on yourself, this can be used to make a paste and cover the area where the coffee or the water, boiling water, fell, and you can cover it, and it prevents blistering. So imagine that, another great use. If you happen to be around poison ivy, again, the allergic reaction can be treated with a paste of this and water, and it helps reduce the itching. For hygiene, if you mix this with hydrogen peroxide, you can make toothpaste, brush your teeth with it for oral hygiene. It can also be used as an exfoliate to get rid of the dead cells on your skin, your arms, your elbows. If you happen to be in a place where you have no deodorant and other people around, you can make a paste and put it under your arm, and that acts just like a deodorant, and you will be okay to be around other people. It's incredible. It's so many wonderful uses. So today I'm going to tell you about how to calculate the percent composition. In other words, we want to find out how much sodium, how much hydrogen, how much carbon, and how much oxygen are in this compound. We'll find out. We are going to focus today on percent composition. Percent of anything is the part over the whole times 100. So percent composition of a compound is done in the same way, is divided by the total mass, then multiplied times 100. For this, you will need a periodic table. You will need to focus on the atomic weights or atomic mass of each one of the elements, depending on what we asked. For example, if we look for sodium, we are going to look at 22.99, depending on your periodic table. If we look for hydrogen, it'll be 1.008. If we look for oxygen, it'll be 15.999. And if we look for carbon, which is the other component that we're going to be looking at, it'll be 12.011. Remember that the molar masses, we add all of those components to get the total mass of the compound, the mass of 1 mole. Once again, a brief overview of how to find the percent composition of the compound. Find the molar mass, find the mass of the component in question, divide the mass of the component by the molar mass, and multiply times 100. Sometimes we find each one of the components, but sometimes we will find just 1 or 2 components. All right, the first thing we're going to do is to calculate the molar mass of the sodium bicarbonate. So I'm going to write Na, and there is 1 Na, 1 sodium, so I'm going to say 1 times, look it up on the periodic table, 22.99, and this is of course grams, and then we have hydrogen, and we have one hydrogen, so I'm going to say 1 times 1.008 grams, and we have carbon, and we're going to say it's 1 times 12.001 grams, and finally I'm going to say oxygen. There are 3 oxygens times 16.00 grams. Back over here, this is actually 12.01, so no 1 there. All right, so now we know that this is equivalent to 48 grams, so 48.00 grams. And now we're going to add all of these, and we pull out our handy calculator, and the total of all this is 84.008 grams. And of course, when I look back, I'm going to cut it off right here, and that's going to be equivalent to 84.001. But it's 2 significant digits, so 0.1. All right, so this is grams, and that's my molar mass. All right, so now if I say I wanted to calculate the amount of carbon in this compound, I could calculate the amount of each one of these by saying, okay, the amount of sodium would be 22.99 grams. 99, this is a 9 grams divided by 84.01. So I'm going to say this is Na. And then I go on and calculate, and this would be times 100 to give me the percent of sodium. And I could go on and calculate the percent of hydrogen as well by saying 1.008 divided by 84.01. And then I can calculate the percent of carbon by saying 12.01 divided by 84.01. 0.01 grams. In each case, these are grams. Grams divided by grams times 100 equals, and this times 100 equals. And finally, I'm running out of room here, but I could calculate the amount of oxygen. So I would say 48.00 grams divided by 84.01 grams, and this would be percent of oxygen times 100. My percentages should add up to 100. So here I end up with 27.36, that's 0.36% of nitrogen. I'm sorry, of sodium. 1.20% of, what's a 0.20% of hydrogen. This is sodium. This is hydrogen. The carbon percentage is 14.30. That's a 0.30% of carbon. And finally, 48 divided by 84.01 is equal to 57.14%. A little messy today. All those percentages should add up to. Here's another type of problem that you can easily calculate the percent. Again, find the percent composition. Here's when a specific sample is given. If you are given a sample of 3.58 grams, you don't have to use the molar masses in this case, but you use the total mass of the compound because it works out to be the same thing. So you would start out by saying, all right, we have carbon, and we have hydrogen, and we have oxygen. And the amount of carbon in this compound is 2.63 grams of carbon divided by the total mass, which is 3.58 grams times 100, give us the percentage of carbon. We'll come back with our handy dandy calculator. For hydrogen, you are given 0.370 grams. The total sample has that many grams of hydrogen divided by the total mass, which is 3.58 grams. And this is multiplied again times 100. And finally, we have oxygen, the mass of oxygen, 0.580 grams of oxygen divided by the total mass, again, part over the whole times 100, 58 grams of the sample times 100. So go ahead and pull out your handy dandy calculator and see what you can come up with. Contains 73.5% carbon, 10.3% hydrogen, 16.2% oxygen, and of course it should total 100%. Perfect. That's it. Take a look at this. We are 100% finished. Percent composition.